All right, looking at Math 2, Unit 3.7. This is Lesson 7, Form K of the worksheet. We're looking at congruence and overlapping triangles. So triangles are basically layered on top of each other is what we have here. So we have, first of all, triangle BAE. Want to know if it's congruent to ABC. And it just says they are congruent. Identify their common side or angle. So the one that these have in common is going to be right there. They're going to have a segment AB. And this shape here, next to it, we have SUV here, and we have WUT. They don't share any lines, but they do share angle U in common. Looking at number 3, we have to separate and draw and redraw the indicated triangles and then identify any common angles or sides. They actually go ahead and they draw it for you. They have ACF, they break it apart to draw it separately, and they want you to see what they have in common. When you look at these guys here, I'm not sure what's easier. It's easier for me to look at them here and go, well, what they share is going to be angle A. Okay? It's hard for me to see what they share in common here, except that they do have the same letter, so that's maybe why they want you to break it apart. But either way, angle A is what they share. When I look down here, they want you to complete the drawing, which they didn't do, so let's do it. They took the one triangle, so the other one that's left is here, and that would be JKH. And again, what do they both have? They both have the JK, which is this line segment right there. That's what they have in common. So we're looking at overlapping triangles. There's two triangles that just share a side, share an angle, and that's what's happening there. Okay, looking at number 5, developing the proof. Complete the two-column proof to show that we want to find that HF is congruent to EG. We're trying to find out that this line right here is congruent to this line right there. Okay, so the way we're going to do that is we have the given information, which says that FEH and GFE are 90-degree angles. So we have 90 degrees here and 90 there. We can see that EH is congruent to FG. Okay, no problem. We can do that, and we want to show that these are going to be equal. Again, if I break this apart, let's see how I separate it here. If I separate it as FGH, here's my F, my G, my E, sorry, my FEH. I have a 90-degree angle, and that equals that. And if I go this way, I got this guy, and I have EFG, and that's 90, and we said that that one equals there, okay? And we're trying to basically prove right now that the, we want the HF, this one, is equal to EG. So we're trying to prove that the hypotenuse of each one are equal and congruent to each other. So first we go with FEH equals EFG, and that's going to be true simply because all right triangles are congruent. They already told us they're 90 degrees, so because they're 90, they're also going to be congruent. Next they say EF equals FE. So right here, EF equals FE, and we can see these share the same line, so that's going to be a line they share in common. So yeah, we can go ahead and say that, and that's going to be because of the reflexive property of congruence is why those are going to be equal there. So we can put a little hash mark, double it up. Those are going to be equal there. We're sharing that line. So now that I have a side, angle, a side, or look here, side, angle, side, side, angle, side. So because I have side, angle, side, now I know, at least for a start, that triangle HEF is congruent to triangle GFE. And since the triangles are going to be congruent, now HF, what's left here, this guy, 1, 2, 3, will have to equal that side. Why? Because corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Okay? So that's what we did for number 5. Let's look at the back side. A few more to go here. And you'll be done and I'll be done. Great fun. Alrighty, here we go. I'm trying to show that these are two triangles that are also going to have some equal parts here. We want to show that AD, this line right here, is congruent to BE, this line here. Okay? Alright. Okay. One thing you want to look at is that, first of all, it says that AFD, and BGE are equilateral triangles. So we know that a lot of these angles are going to equal each other on the inside. Okay? It also means that if it's equilateral, this little guy equals that little guy, which means that I have 60 and 60 there. I'm also going to have equal there, but it doesn't really matter. But I'll put it there for fun. So angle A and angle D are congruent to AFD, and the reason for that is if I have, let's see, what do we have right now? We have, oh, they're equilateral triangles. Since they're equilateral, that tells me that all the sides are the same, right? So the sides are the same. So because the sides are the same, now I'm saying that if the sides are the same, my angles are the same, and that is the corollary to Theorem 20. The same is true over here. If this is an equilateral triangle, BEG, equilateral means equal sides, then also the angles B and G are also equal to BEG. So that's a corollary as well to Theorem 20. So essentially we're saying these sides equal, and this is going to be 60 on the inside. We're all good. Angle A equals angle B, that's a given. Angle A from step 5 equals D, which equals B, which equals G. So they're all the same thing, and that is referred to as a transitive property of congruence. Transitive property of congruence. Just moving things around, they're all the same. This is to that, and this is to that. And then we go to EF equals FE. So we're looking at this little space right here. What's interesting, if you look at our initial given, which we haven't given, it's number 7. Number 7 tells us that DE, this little line, is equal to this little line. It kind of ignores that space right there. So what they want us to do is say that EF equals EF, and they're going to equal each other because of the reflexive property of congruence. Your eyes might have missed that, thinking that this was already saying those are equal, but it ignored this part. So we're going to say this part equals each other. EF is equal to each other. Now we already were given that DE equals this. No problem. So in step 8, we want to say that this part plus this part is equal to this part plus this part. And that is considered the addition property of congruence. I'm adding up parts that are equal to each other to make a bigger part that's equal to each other. Is the idea there. Number 9, DF is going to equal EG, and that's the segment addition property. We just did that. So now we're going to add them together. Here we had DE plus EF breaking apart. So now we're going to just say D all the way to F is equal to E all the way to G. And that's the real new postulate. It's a segment addition postulate that allows me to do that. Now this point here, because I know this, I have angles equal, I have sides that equal, and for what we have here, we really have angle. We've proven an angle, and now proven a side. We can say the triangle AFD D is congruent to triangle BGE by angle, side. And what we're left with then is that now that we know it's a triangle, we can officially say that this guy equals this guy. Why? Because corresponding parts of congruent triangles are congruent, or corresponding parts of congruent triangles are congruent. I don't think you do that. I'll ignore that for now. Alright, number 7. It wants you to draw a line segment in paper. There it is. Then draw 2 overlapping congruent triangles that share the segment as a common side. So, let's see if I draw a line here and here. That's a triangle. And if I draw a line here and here, triangle. There you go. Number 8, draw 2 triangles that share a common angle that is not a right angle. Okay. So if I go like one of these funny little guys like this, and then I go this way and go, alright, fine, we'll go that way, and we'll go this way. Now we can have an angle. Okay, sure. Alright. And number 9, our last one of the day, and for me, last one of the night. We have square tile floor. If ACF and DBG are 30, 60, 90 triangles, write a pair proof to prove that FGE is equilateral. Alright, sure. So, here's what I have. Here's how I do it. If this is 30, and I know this is a square to start with, this is a 90 to start with, what I have left right here is 60 degrees, which means what I have left here is 60 degrees. If those two are 60, what I have remaining from that, 60 plus 60, is 120. You good with that so far? 120. What I have left at the top is going to be 180 minus 120, which is 60. So at least so far I know I have an equilateral triangle. Okay? So because the complements of 30 is 60, and they're all there by the angle sum theorem, so because it's equilateral, because I know that equilateral by theorem 20, if it's equilateral, then I also know the corollary to that is going to be, is it 21? It's going to be, this will be equal sides as well. So there we go. So equilateral by theorem 20. And that's all I got for the day. Hope that helped a little bit. Proofs are not my thing, but hopefully you're catching on. Thanks.